Hey, fellow problem solvers, Colfax Math here. The only way you learn anything like juggling is through practice. That's true for mathematics as well. I've been teaching high school woodshop and math for a very long time, and I've been making math videos for a long time as well. And the number one comment I get is, how do I get back in the game? I'm 25, I want to join the military, I want to pass the ASVAB exam, but I really forgot all of my math. So what I've decided to do is write a relatively short workbook coupled with 25 videos that'll help you get back in the game, help you learn foundational math and Algebra 1 so you can succeed on any standardized math exam. The way I have it figured out is there'll be 25 chapters, 25 videos. Every video will be about a half hour. So within, I'm hoping, under 45 minutes or so, you'll be able to work through the chapter in the book while watching the video. So I will be there with you, working through this whole workbook together. And then within a month, doing that every day for less than a month, at the end of a month, you'll really have a solid foundation in math and have completed Algebra 1 and will do well on any standardized math tests. I've split this whole course into 5 parts: foundational skills, intro to algebra, advanced algebra, geometry and applied applications of algebra, and then test-taking strategies with sample tests. Again, each part will have about 5 chapters in it. Every chapter will have 1 video, so I can work with you. You can comment, and I'll get back to you as quickly as I can. I'm going to make it as interactive as possible. And in this workbook that I wrote, I'm going to leave places for you to take additional notes. You won't have to have that many notes taken. The majority will be in the workbook, but then I'll leave little spaces where you can write in your own notes, do the practice problems along with me. And I think it might be a great course for a lot of people looking to get back in the game, really missed out on that portion of math in their lives and looking to regain it. It will, in fact, give you such incredible opportunities when you have that foundational math base. There's really unlimited potential once you get that starting place in Algebra 1. All right, with that said, let's go ahead and go to Part 1, Chapter 1, and get started in the foundations of math. Make sure, if you don't have this book, that you have a notebook in front of you with paper and pencil, that you pause the video, do the problems before I do them, take notes. That process of writing stuff down really helps you learn the math. All right, let's go on this journey together. I'm glad you're here with me. Thank you. All right, let's jump all the way down to Chapter 1. In this chapter, I'm going to go over integers, fractions, decimal, percentages, and the relationships between them, order of operations, absolute value. I'm going to break this chapter up into different sections. So this is going to be section 1.1, integers, 1.2, fractions, 1.3, decimals, 1.4, percentages, the relationships, 1.5, order of operations, 1.6, and absolute value, 1.7. Make sure you have this book out in front of you, or if you don't have the book, at least have a notebook out, take some notes, pause the video frequently, do problems, take notes to yourself. The process of actually taking notes really helps make that stuff stick in your brain. Makes a lot of sense. It's really kind of how you acquire knowledge, by working through problems. And if you have the book in front of you, I'll leave a lot of room for you to take those notes. If I'm going too slow for you, you could turn up the speed on the video, or if I'm going too fast for you, you could slow it down. It's really up to you. Okay, so what we're going to start with in Chapter 1 is really integers and numbers and a sense of numbers. An integer is a number, a whole number, without any decimal or fractional parts. Within that number, there are going to be positive integers, 1, 2, 3, negative integers, and also a 0. Kind of how all of this math is based on is this idea of a number line. And it's a really big idea that we're going to use throughout this whole course. So go ahead and create a number line right here. This number line has arrows on the end to say that it's infinite in both directions. Right in the middle of that number line is a 0. And then I go over 1, 2, 3, 4, 5 onwards. And then going this way, I go -1, -2, -3. And I know it seems kind of basic, But what we're going to do next when we look at fractions and decimals and percents, we're just going to take that 1 unit and expand it way open like a Google map. You know how you zoom in? And then we're going to split that into halves and eighths, convert those to decimals and percents. After we get all that done, as we move into algebra, we're going to call this our independent variable x. And then we're going to create a vertical line through there, and we're going to go from one-dimensional space into two-dimensional space, graphing coordinates, graphing lines. So this number line is really a big foundation. If you're trying to add integers, I try and put this thing in my head, and I'm bouncing all over this thing depending on what I'm doing. So if I'm adding integers, if I just have 1 plus 3, that means I start here. Plus means I go to the right, 1, 2, 3, and end at 4. If I have 1 minus 3, that means I go to the left. I start here, 1 minus 1, 2, 3, and I end at -2. So I'm trying to put that number line in my head. If I have -2 plus 5, I'm saying start here, go over 5, end at 3. If I have -2 minus 2, well, that's saying start here at -2, go that way, 2 more, 1, 2, and this is going to be equal to -4. So that's how I do addition and subtraction. I always try and think about where I am in the number line. Remembering this plus means go to the right, this minus means go to the left, and it doesn't really matter where I start, positive or negative. If I have -3 minus 2, what that's really saying is -3 plus -2. So I start at the -3, and I'm going that way, put this minus, and I go down 1, 2, end at -5. If I have -3 minus -2, this is still saying start at -2. Minus is going to the left, but go to the left of a negative. The way I remember that one is there's like a guy on a diving board right here. He jumps up off of that diving board, boom, breaks through the surface of the pool. The negative is really saying positive. So -3 minus -2 is the same thing as -3 plus a 2. I start right here. -3 plus 2 would just be here at -1. All right, here's some practice problems here. What you're doing in your head, trying to visualize that number line. You're starting at -7 and you're adding 12 to it. And you got to get really good. You got to do a lot of practice of these for these to come. Pause the video, make sure you get these really quickly. -7 plus 12 is 5. -15 minus 23, that's saying start at 15, go that way 23, end at -8. -9 minus 6, minus, so I'm starting at -9, going that way 6, so -15. So that's addition, subtraction. Here's the important rule to remember for multiplication and division. A positive times a positive will always equal a positive. A negative times a negative will equal a positive. A negative times a positive will equal a negative. And a positive times a negative will equal a negative. So for multiplication and division, I'm just looking at the signs. If the signs are different, the outcome's negative. If the signs are the same, the outcome's positive. So -4 times 8, well, I'm multiplying those two numbers together to get 32. And I got one negative, so it's got to be -32. Negative times a negative, that's got to be a positive. 33. This is division. 24 divided by -6. Positive divided by a negative. Got to be a negative. -4. That asterisk is used a lot for multiplication. Negative divided by a negative. How many 9s go into 36? 4. Now I have 3 operations here. I'm starting way over here. -10 plus 4. That puts me at -6. -6 minus 7, saying go that way to put me at -13. Hopefully you're getting the hang of these integers. I know it's a bit of a review. Sometimes something you've heard a million times never really made sense, and then you revisit it and it does make sense. So hopefully this is coming together and we can move forward. There's some more practice problems in the book as well. All right, let's jump to section 1.2, fractions. Think about fractions. A lot of people have a lot of trouble with fractions. Some people call it the F word. I'm going to create that same number line, but this time I'm not putting arrows on it. I am only going to look at 0 to 1, right? So like I was saying in that last part on that number line, I'm taking that thing and I'm zooming way in on it, just like on a Google map. And the way, especially in the US, all measurement is used fractionally like this. So I'm going to take that 1 inch and I'm going to cut that in half to get 1/2. Then I take that half and I cut that in half to get 1/4. So now I have 1/4, 1/2. This distance is a half. I cut that in half to get 3/4. Whoops, thing isn't going to work on me now. 3/4. And then I want to cut those in half. Cutting it in half is the same thing as doubling the bottom number. So I cut 1/4 in half to get 1/8. This is the equivalent of 2/8. This would be 3/8, 4/8, 5/8, 6/8, 7/8, and then we're back to 1, which is 8/8. Then I'm going to cut those 8s in half to get 16ths. So this would be a 16th, 2 16ths, 3 16ths, 4 16ths, 5 16ths, 6 16ths, and so on. The thing about a fraction, it is not a whole, it's a piece of a whole. So 1/2, you could see it linearly like this way I do it, or you could see it in this way as well. If this circle is 1, well then this is 1/2. If I cut that half in half, this is 1/4 or 3/4. I cut that 1/4 in half. This is now 1/8. I cut that 1/8 in half, and so forth. There is no difference between 1/2 and 4/8. They are equivalents. You always want to write your fraction in the reduced amount. So if you have 4/8, you could see 4 goes into here once, 4 goes into here twice, but it is still equivalent. If we have equations later in algebra, we could do whatever we want on either side of equal sign to keep that thing balanced. But the majority of time with fractions, they are not in equations, they're in expressions. So what that means is if I have 3/8 and I want to add it to another number that has a different denominator, like 1/16, the way I add is I have to have a common denominator, and we'll go over more of this in future chapters. But I'm just going to multiply this by a factor of 1. This is a really big idea with fractions. I'm multiplying by 1 doesn't change the value of anything because I'm multiplying by 1, but now it'll give me 6 on the top, 16ths on the bottom. Now I could add across the top and keep the bottom the same. That's how I get a common denominator. And this is an idea of equivalence, right? 6/16 is the equivalent of 3/8. I go from here to here by multiplying by 1. A proper fraction, the numerator is less than the denominator, like 1/2 or 3/4, anything less than 1. An improper fraction, now all of a sudden the top number, the numerator, is greater than the denominator. And you could always convert an improper fraction into a mixed number. And that mixed number is going to be a whole number plus the fractional part. So if I have this improper fraction here, 5/3, and I want to convert it into a mixed number, I think about how many times does 3 go into 5? It goes in there 1 time. How much is left over? 3 goes into 5. 1 time with 2 left over. It's a 1 2/5. This is a mixed number. This is an improper fraction. Okay, there are 4 main operations in all of math: addition and subtraction. And again, this is a future chapter where we're going to spend a lot more time on this. But to add and subtract fractions, you have to have a common denominator. Once you have that common denominator, you add across the top, keep the bottom the same. Multiplication, see if anything can cancel. You can do this or not or cancel afterwards. And then multiplication is the easiest. You multiply across the top, multiply across the bottom. Division, you multiply by the reciprocal. Again, I'm just kind of planting those seeds for when we go into the fraction chapter. All right, section 1.3, decimal. Decimal is just another way to represent a part. Usually with decimals though, I'm not splitting this thing in half and half and half to get my h. I'm splitting it into 10 equal parts. And the thing is we use a base 10 number system, so it's pretty easy. So if I have this number here, 2.1, that is saying that is 10 100ths or 1/10 of a unit. This decimal point is saying the parts are afterwards. So if I have 32.14, this is 14 100ths. If I have 0.145, that is 145 thousandths. So this is my tenths place, my hundredths place, my thousandths place. And then this is my 10,000ths place. And it's called my 10,000ths place because this is 1,456,000 over 10,000. Splitting that thing up into 10 pieces. This is my ones place, my tens place, my hundreds place, my thousandths place, my 10,000ths place. Every thousand you're going to put a comma in there. So this is 65,432.1456 or 65,432, 1,456 10,000ths. So if you want to find the equivalence, right? We talk a lot about equivalence, and I have 0.5, and I want that as a fractional equivalent. Well, that is 0.5. That's in my tenths place. So that is the same thing as 5/10. I take that decimal, put it into a fractional form this way. Then I look to reduce it. 5 goes into here 1 time. 5 goes into here 2 times. These are equivalent. This is a reduced fraction. This is a decimal, the equivalent of 5/10, the equivalent of 1/2. All right, here's an example here. Convert 0.75 to a fraction. So the way I do that is 75 100ths. Once I have 75 100ths, I look to see what the numbers are divisible by. Well, 25 will go into there 3 times. 25 goes into there 4 times. 1.4 percentages. A percentage is just another way to represent a part of a whole. 1 is equal to 1.0, which is equal to 100%. So, we split that thing up on the first number line into eighths and quarters. And then for decimals, we split it into slices of 10. Now we're saying the whole thing is equal to 100. And I want to split it into 100 little pieces. So if I have something like 50%, it is the decimal equivalent of 0.50. The way I remember this is if I have 50%, this pen's giving me about 50%. If I have 50%, I think of this thing right here is an arrow. And this arrow is saying the decimal place is here. Shoot it over 2, 1, 2. So 50% is the equivalent of 0.5. Or if I have 0.25, I want to move the decimal place over here, 1, 2, to get 25%. Converting percentages to fractions. So what you want to do first is you want to really take that 75%, knowing that it's 75 parts of 100. 75 cents is 75 parts of $1. Take it over 75 over 100. Again, you want to see that 25 goes into here 3 times. 25 goes into here 4 times. So 75% is equivalent to 75 over 100, is equivalent to 0.75, is equivalent to 3/4. Section 1.5, relationship between numbers. So if I had 0.25, go ahead and convert that into a percent first. That goes 1, 2, 25%. Convert that into a fraction. 0.25 is 25 100ths. 25 goes into there 1 time, into there 4 times. These are all equivalents, and you should be able to go back and forth between these. 0.25, 25%, 1/4. Okay, section 1.6, order of operations, and then absolute values, and we'll wrap the chapter up there with a few practice problems. So a mnemonic device to remember order of operations is PEMDAS, parentheses. You always do your parentheses first. Then you do exponents, multiplication and division. That's that MD right there. Doesn't matter which one. And you do whichever one first from left to right. And then after that, then addition and subtraction. Again, subtraction and addition have the same way. You work left to right. So let's take a look at this example right here. 2 plus 3 times 4. I would have to do my multiplication first. 3 times 4 is 12. Then I add my 2 to it to get 14. Here's another example. Don't look at the answer. Pause the video, make sure you get it. Here I have parentheses, so I have to do those first. 2 plus 3 is 5. Then I have 5 times 4. Left to right is 20. Okay, we do a couple more here. Let's say I have 5 minus 7 times 2 plus 3 minus 4 in parentheses. So first thing I'm going to do here are my parentheses. I have 5 minus 7 times 2 plus -1. Still working left to right. I got to do my multiplication. So I have 5 minus 14 plus -1. Working left to right. 5 minus 14, -9. -9 minus 1, -10 is the correct answer here. All right, moving on to section 1.7, absolute value. Absolute value is pretty easy. It just means whatever's inside of these straight bars is positive. It doesn't really matter what's in there. Whatever it is becomes positive. So absolute value is a way to take distance and always make it positive, whether you're traveling in a positive direction or negative direction. It is the overall distance. So the absolute value of -5 is 5. The absolute value of 3 is 3. The absolute value of 5 minus 6. Well, 5 minus 6 is equal to the absolute value of -1. Absolute value of -1 becomes positive and gives you 1. All right, let's go ahead and do some practice problems down here. Don't look at the answer key yet. So number 1, pause the video and do these problems, and then unpause the video and watch how I do them. All right. All operations are addition and subtraction. PEMDAS isn't going to really come into play. I'm just working left to right. -8 plus 5, -3. -3 minus -3, that's like that diving board thing. So -3 plus 3 is going to give you a 0. Number 2, convert 3/8 to a decimal. So I have 3/8. I want to convert that to a decimal and then a percent. This is a little tricky. The way I do these right here, because it's not going to work out evenly, is I think of this fraction and it always falls over to the right. And I'm going to go 8 and 3 this way. And I'm saying, how many times does 8 go into 3? Well, that's the same thing as 3.0, right? 3.000 is still 3. 8 goes into 30 3 times to give me 24. That decimal place stays up there. 30 minus 24 is 6. I bring down the next 0. 8 goes into 60 7 times to give me 56. 60 minus 56 is 40. 8 goes into 40 5 times. That decimal point goes right up there. So 3/8, the decimal equivalent of 3/8 is 0.375. If you're a machinist, you probably got that one right away. 0.375 and 3/8 are equivalent. And then take that decimal and convert it to a percent. I go over 1, 2 to get 37.5%. And that was 0.375. So that's how I go from fraction to decimal to percent. Calculate 15% of 80. We got to take that 80, multiply it by the decimal equivalent of 15%. So that thing goes over 1, 2. Give me 0.15. So 80 times 0.15. I multiply the first number across all of them, 5 times 0. 5 times 8 is 40. I have a placeholder here. 0.1 times 0, 1 times 8. I add down 0, 0, 12. Then I count up the decimal places here. It's over 1, 2, so I go over 1, 2. So 15% of 80 is equal to 12. If that was a little bit hard, that's okay, because we're going to go over a chapter on decimals coming up. And then lastly, or not lastly, 2 more problems. Simplify. We got 3 operations: addition, multiplication, parentheses with subtraction. So I got to go my parentheses first. So I have 2 plus 5 times 6 minus 4, which is 2. Left to right, I got to do multiplication first. 5 times 2 is 10. 2 plus 10 is 12. And then evaluate this right here, this expression. Absolute value -7 is 7. 7 plus 2 is equal to 9. All right, well done. I know it's a long video. Hopefully a lot of this was review. It's great that you're here making this work. Even if you remember pieces of this, maybe going through it before we move on to the other 24 chapters, probably time really well spent. Again, the key to learning here is you got to do a lot of practice. You got to practice with that pencil and paper and do problems, take notes. I hope this is helpful. I'm working on this as fast as I can. I'll post this one first and then work through the next 24. I'll definitely get one out every week, if not sooner. And then I'm working on this book as well to get out as soon as I can. If you're new to the channel, think about subscribing. Hit that notification button so you'll know when new ones come out. I teach both high school math and woodshop. I love woodworking, love everything about woodworking. I like the applications of math, but I also teach math and kind of all levels. So I do post other videos on my channel that won't be related to this. So just make sure you look for the ones that are titled in this series, Math Test Success. It'll also be a playlist. Thank you for watching.